This is for Algebra 2. We're looking at roots and zeros today. And a zero is the value you can substitute for x that will give 0 as the result. The fundamental theorem of algebra states that for any polynomial with a degree greater than or equal to 1, you're going to have at least one zero. The number of zeros it has will be the same as the degree of the function, which we talked about before. One thing you do need to understand is that some of your zeros may be the same. So remember when we had double roots in the past, x minus 3 and x minus 3, so you had a double root of 3. That's possible, and that counts as two zeros. We have something called Descartes' rule of signs, and it helps you determine how many zeros are real numbers and if they're positive or negative. So you make sure your coefficients are all real numbers, you write it in descending order of x, and then you find the possible number of positive zeros, which is going to be the number of times the coefficients change signs. Then you subtract 2 and continue until that answer is negative. The positive answers are the number of positive real zeros. To find the possible number of negative zeros, you change your x to negative x throughout the entire function, and then count the number of times the coefficients change signs, subtract 2, continue until you have a negative answer, and the positive answers are the number of, that would be negative real zeros, not positive right there. So there's a summary of it. And to find the zeros of a polynomial function, if one of your zeros is given, you look and see how many zeros you should have, which is the degree. You use the one they gave you and the factor theorem that we learned before, and find a factor. Use synthetic division, and then continue breaking it down so that you can find and list your zeros. So let's look at the next page. And they've given us a function, and they have told us that you know that 1 is a 0. Well, first of all, figure out how many zeros are there. And you look at your degree to figure this out. And my degree is 3, so there are 3 zeros. So start by using synthetic division, knowing that 1 is a 0. So I'm going to do 1. I'm going to pull over here 1, negative 3, negative 13, and 15. Bring down your 1. 1 times 1 is 1, negative 3 and 1 is negative 2. 1 times negative 2 is negative 2. This gives you negative 15. 1 times negative 15 is negative 15, and you get 0. So this becomes x squared minus 2x minus 15. So you would factor that. Signs are going to be different. The largest one is negative. And the factors of 15 that when you subtract give you 2 are 5 and 3. If you can look at it like what I just did and come up with your factors, that's fine. If you need to come over here and list the factors of 15 and use your sign rules, that's okay also. So now we know that our factors are x minus 5 and x plus 3. And they told us that 1 was a 0. Remember, when you write that as a factor, you will use the opposite sign. So it's actually x minus 1. So those are your factors. Your zeros are going to be the opposite signs of what you have in here. So this would be a positive 5, a negative 3, and a positive 1. So on this next one, they don't give us a possible, or one of the roots, or one of the zeros. So we just kind of have to look at it and start by saying, okay, how many zeros will there be? Well, my degree is 4, so there should be 4. Then you want to use, we're not going to do this the way it's set up here. You want to use Descartes' rule, okay? Use the rule that we talked about, and let's figure out how many positive and how many negative answers or zeros we're going to have. So first of all, you look and you got to figure out the number of sign changes, okay? I go from positive to negative, that's a sign change, back to positive, that's another one. Stays positive, goes negative, that's another one. So there are 3 sign changes. You understand that this is a sign change, this is a sign change, this is not one, this is. So then you subtract 2. Well, 3 minus 2 is 1. Keep doing that until you get a negative answer. So 1 minus 2 is negative 1. Okay, so that's as far as I have to go. The positive numbers you have listed here, okay, are going to be how many positive zeros you have. This is a positive number, and this is a positive number. So there's either 3 or 1, positive 0. So then for the negative, you've got to rewrite your problem and you change the sign for each of your x's. Now, this means that if this is your x, not the whole term, so this is like saying 3 times negative x to the 4th. As long as it's to an even power, it does not change anything. This is still going to be 3x to the 4th. But if it's an odd power, it's like saying minus 8 times negative x, that's an 8, to the 3rd. Well, negative x to the 3rd is negative 1 times negative 1 times negative 1, which is a negative. So this right here changes. This becomes plus 8x to the 3rd. Even degrees are not going to change, so it stays plus 8x squared. It becomes minus 11x, and it stays minus 8. So now when I look for sign changes, positive, 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 negative, negative, I have one sign change, right? Which tells me 1 is where you start with, right? So 1 minus 2 is negative 1, so that's where I get to stop. This is my only positive, so there is one negative. Okay, I said there was either 3 or 1. I said there was a total of 4. If there's one negative, there must be 3 positive. So I'm going to have 3 positive zeros and 1 negative 0 for my answer here. We're not actually going to find the solution, we're just describing what they're going to be. All right, go on to the next page. So that description was your answer, 3 positive, 1 negative. All right, use the fundamental theorem to find the zeros if you know that negative 1 is a 0. So when you know that, you start using synthetic. We've got 3, we have a skip, so we're going to put a 0, negative 7, negative 4. Bring down your 3. You have negative 3, negative 3, positive 3, negative 4, positive 4, 0. So this becomes 3x squared minus 3x minus 4. You could find the factors of 12. You could use the quadratic. I'm going to use a quadratic on this one. So remember, this is my a, this is my b, and this is my c. Quadratic is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to have 3 plus or minus the square root of negative 3 squared is 9, minus 4 times a is 3 times c is negative 4, all over 2 times 3 is 6. So then I'm going to have 3 plus or minus the square root of, when you put all of this in, you're going to get 57, and it's all over 6. Now you need to look and see, will that break down? 57. No, it won't. It would divide by 3, but it's not going to get you anywhere, I don't think. 3 will go into that 1, 27, 9. So it doesn't get you anywhere. It's wasted effort. Okay, so we need to find all of our zeros. We know that negative 1 is a 0. You could put this in your calculator, and you could go 3 plus square root of 57. Get out from under your square root. Either close parentheses or press your right arrow. Enter, divided by 6, enter. And I get 1.8. So another solution is 1.8. And then I'm going to do it again, but I'm going to subtract. So 3 minus the square root of 57. Get out from under. Enter. Divided by 6. Enter. Negative 0.76. So the other one would be negative 0.76. And you have your 3 roots. I know there were supposed to be 3 roots or zeros because my degree is 3. Use Descartes' rule of signs to determine how many are real numbers and if they are positive or negative. Okay, well, first of all, look at your degree, and there should be 4. So we're going to look for positive first. Count your sign changes. I have a sign change here, here, here. So I'm going to say 3 minus 2 equals 1, minus 2 equals negative 1. So that's where I get to stop. I have a positive, and I have a positive. So it's either 3 or 1 positive, because those are the numbers I circled. So then to find your negative, you got to go in there and change some signs for all of your odd degree. So 4x to the fourth plus 8x to the third plus 6x squared plus x minus 5. So when you do this, right here is your only sign change. So there is only going to be 1, because 1 minus 2 is negative 1. So this is it. So you know you're going to have 3 positive and 1 negative 0. You don't know what they are. You just know how to describe them. Okay, so let's say we have a problem. X to the third plus 3x squared minus 10x minus 24. And they don't give you a starting point. Okay? First of all, how many zeros should there be? The number of zeros. You look at your degree, and the largest is 3, so there should be 3. To find your starting point, you want to put the original problem into y equal. So we're going to say x to the third plus 3x squared minus 10x minus 24. Now stop and think about it. If I were to look at the graph, where are my zeros? They're the points where the graph crosses the x-axis. Well, when it crosses the x-axis, the value of y is 0. So go to your table and look for where y is 0. You will actually use the number for x. So when y is 0, x is negative 2. One of my zeros, one of my solutions, okay, is going to be negative 2. Because that's what the x is. So then I'm going to use that number for my synthetic division. So negative 2, I have a 1, a 3, a negative 10, a negative 24. Bring down my 1, negative 2, 1, negative 2, negative 12, positive 24, 0. So then that leaves me x squared plus 1x minus 12. And you either see if you can factor it, or you use your quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This one actually factors. It becomes x plus 4 and x minus 3. And so if x plus 4 is a factor, negative 4 is a 0. If x minus 3 is a factor, positive 3 is a 0. And here's my final part of the answer. There were 3 zeros. This is what they are. If it doesn't factor, then you would have used your quadratic formula. But what I was trying to show you here is your starting point. If they don't tell you what one of the zeros is, you have to look at your calculator. Sorry about that. Go to the top. Look at your calculator to find your starting point, which was our negative 2.